Hello and Assalamualaikum. My name is Luqman Hakim bin Muhammad Rasli. I am from Group 4 and will be presenting topic 4.3, which is engineering ethics. So under this topic, there will be three subtopics, which are engineer utilitarianism, code of ethics, and professional negligence and liabilities. So we are going to start with the introduction, which is what is engineering ethics. So, engineering ethics can be defined as the study of decisions, policies, and values that are morally desirable in engineering practice and research. And then, what is engineering? So, engineering can be defined as the process of developing an efficient mechanism which quickens and eases the work using limited resources with the help of technology. So there are many examples of engineering, which are electrical engineering, mechanical engineering, chemical engineering, and civil engineering. Then we are going to the next topic, which is what is ethics. So the word ethics originates from the Greek word ethos, meaning character. Ethics can be defined as the principles accepted by the society, which also equate to the moral standards of human beings. And then we are going to watch a short video on what is about engineering ethics.
We all make mistakes. In life and engineering, you're not always going to succeed. What's important is that you learn from your screw-ups and incorporate those lessons into what you do next. Because when you don't, the consequences can be bad, even deadly. To help keep us on track, we need something that will provide a sense of morality and a set of best practices for doing good in the world. We need ethics. Specifically, we need engineering ethics. Engineering is a broad, ever-changing field. With so many different branches, it's good to have some common ground, a general set of guidelines or ideas for how the engineers of the world should go about solving problems. One of these is safety, which we'll talk about more next time. The other is ethics. In general, ethics is a moral philosophy that tries to deal with what's right, what's wrong, and what your duty is to do good and not do bad. Engineering ethics is essentially the same mindset, just applied to the field of engineering. It's the study of values, issues, and decisions that are involved with the work of engineers. Ethics has a particular importance for engineers because people's lives are so often going to be in your hands. It's not just about remembering your manners or being nice to your neighbour. What you create as an engineer could save a person's life or take it away. When you swallow a pill at the hospital, you need to be able to trust that the people that came up with it had your best interests in mind. When you drive over a bridge, you need to know that the civil engineers who designed it took the time to make it as sturdy as possible. The foods you eat, the cars you drive, the wires in your home, they all need to be designed with ethics in mind. If you want to see how bad an engineering failure can be, look no further than the Kansas City Hyatt Regency collapse. In July of 1980, the Hyatt Regency Hotel in Kansas City, Missouri, was showing off its new multi-story atrium, decked out with 2 levels of suspended walkways. These walkways were supported by beams which were supposed to be held up by long rods hanging from the ceiling. To even the load and reduce the stress on each beam, the walkways were supposed to have a single rod extending all the way through them. But something happened between the initial design stage and the actual building of the atrium. When the builders had some difficulty putting it together, the system was modified to have 2 separate shorter rods instead of a single longer one. This design change meant that the upper rod had to not only support the weight of the walkway that it held up, but also the one below it, essentially doubling the load. During a party about a year after the atrium opened, these beams failed and the 2 walkways collapsed, killing 114 people and injuring 216 others. In terms of lost lives, it was one of the most devastating structural failures in US history. A lot went wrong, much of it caused by poor oversight and bad communication. A formal review of the changed design never happened, strength calculations were never performed, work was subcontracted out, And the engineer on record put their seal on the design without personally checking everything. It all could have been prevented if only they'd followed the engineer's code of ethics. There are a couple of different ones out there, but today we'll use the code of ethics from the American Society of Civil Engineers, or ASCE. Their code of ethics has 8 distinct principles, the first being hold safety paramount. This means that your chief concern as an engineer needs to be the health and welfare of the public. The rule goes on to say that you should only approve designs that are determined to be safe and that conform with accepted engineering standards. The fact that there weren't any calculations done on the design changes to the walkway and that the engineer on duty approved the designs without properly checking them clearly goes against this principle. That's why the Committee of Professional Conduct that reviewed the case ruled that the engineer had violated their code and suspended them from the society for 3 years. If you take a look at the rest of the code, you can see some other useful rules about how engineers should approach a problem. The second rule is to service with competence, which means that you should only work in areas that you're skilled in. If you're not an electrical engineer, you shouldn't be messing with the wires in a building. The third states that you should always issue true statements. Basically, don't lie. Then comes the need to act as a faithful agent for each of your employers or clients and avoid conflicts of interest. One of your jobs shouldn't cause you to sabotage another. There's also the rule of reputation by merit, which means your reputation is built up by the work that you do and not by unfair means. That goes hand in hand with the requirement to uphold professional honour, where you act with integrity and have a zero-tolerance policy for bribery, fraud, or any sort of corruption. The seventh rule is to continue professional development, and it's one of the most important for the long-term growth of society in the engineering field. You need to not only foster your own development as an engineer, but that of other engineers as well. You always need to report what happens, no matter the consequences. And finally, the eighth rule is to treat all persons fairly, which is really just a good mantra for life. Now, codes are great, but they're not perfect. People can and do break the rules, and codes can't always address every situation. They may need to be updated as society and technology advance. So it all comes down to this. What are the highest priorities? If engineers are trying to create good for the public, you need to ask, what is good and how can we prioritise good? It can't just be consequentialism, having the end justify the means, or you leave the door open for some pretty big ethical grey areas. No, we need better ethics than that. One of the most influential ethical theories to engineering has been utilitarianism. This is the belief that actions are right if they're useful or beneficial to the majority of people. You should try and maximise the overall good that you can do, taking into account all of those that will be affected by your actions. Rights ethics is also very important. Simply put, you should do your best to respect the rights of others. Acts of respect aren't just ideal but necessary, regardless of whether or not they always maximise the overall good. In that way, you can see how ethical theories can stack on each other. There's also duty ethics, which is all about respecting another person's autonomy. This builds on rights ethics, but puts the spotlight on your duties rather than another person's rights. If you have a right to live, then I have a duty to not market a misleading product that could kill you, or sign off on a new walkway design that I haven't checked. Applying engineering ethics is all about trying to balance these ethical theories with whatever situation you're put in. It's not always easy or simple, but as an engineer, you have a duty to try your best. We improve individually and as a community with practice and learning from the past. Remember that City Court building we talked about last episode? The one whose pillars were in the middle of its sides rather than at the corners. Wind from the wrong angle could cause the entire structure to fall, and no one realised until a student pointed out the problem after it was already built. After those discoveries were made and they started immediate repairs, did they have an obligation to inform everyone in the building? How about the church that was underneath it? What about the people in the surrounding area, or the media, or the local government? What was the proper protocol that they should have followed? If you pick apart this incident, you can zero in on the ethics surrounding several of these points. To start, you need to analyse those wind loads. You need to check all of your calculations and not simply rely on building codes, which only set minimum requirements and aren't always what a specific project needs. Then you should address the design changes, which in this case was a switch from welded connections to bolted ones. Those changes need to be considered in the overall design and checked by everyone involved. It can't just be a hasty decision. You also have your professional responsibility to follow the codes of conduct for every chartered institution that applies to what you're doing. Public statements are absolutely necessary in a situation like this. The public has a right to know what's going on so they can plan accordingly. If you don't release a public statement, or like City Court put one out that's misleading, you're denying people their right to ensure their own safety and make their own educated decisions. Finally, no matter what happens, you need to share and contribute to the advancement of professional knowledge. Concealing the City Court problem for over 20 years robbed everyone of decades of ethical and engineering learning. That's why even when tragedies happen, it's important to treat them as case studies on what you might learn to do differently in the future when approaching other problems. Like if you're going to try and go into space, you need to know about the Space Shuttle Challenger disaster. In 1986, a leak in one of its solid rocket boosters ignited the main liquid fuel tank, resulting in the loss of the vehicle and the death of the crew. NASA found the cause of the disaster to be the failure of an O-ring seal in the solid fuel rocket. And while there were many factors that contributed to this disaster, it was fundamentally an ethics problem. Sufficient testing hadn't been done on the O-rings, and NASA management didn't listen to the concerns of some engineers, all so they could stay on their launch schedule. Who knows what would have happened if a better ethical code was followed? It could have still gone wrong, but maybe it wouldn't have. All we can do is try, and with a strong code of ethics at our side and knowledge of the past at our backs, we can make the best, most informed decisions to ensure our designs have the best possible impact. There's no better way to do it. Today we talked about ethics and how it can be applied to engineering. We learned what a code of ethics is and how it can apply to a situation like the Kansas City Hyatt Regency collapse. Then we learned about engineering ethics and the ethical theories of utilitarianism, rights ethics, and duty ethics. Finally, we brought it all together by going back to the situation with Citicorp and analysing it from an ethical perspective. I'll see you next time when we'll talk about safety. Crash Course Engineering is produced in association with PBS Digital Studios, which also produces Origin of Everything, a show that explores the history behind stuff in our everyday life, from the words we use, the pop culture we love, the technology that gets us through the day, or the identities we give ourselves. Check it out at the link in the description. Crash Course is a Complexly production, and this episode was filmed in the Dr. Cheryl C. Kinney studio with the help of these wonderful people, and our amazing graphics team is Thought Cafe.
So okay, we have done watch a short video on engineering ethics, which is the introduction. So we are going to move on to the next topic, which is the first subtopic, engineer utilitarianism. So what is engineer utilitarianism? It can be defined as the philosophy which explains that the happiness or pleasure of a greatest number of people in the society is considered as the greatest good. So by this philosophy, an action is morally right if its consequences leads to other people's happiness, and it will be wrong if the action leads to their unhappiness. So this theory moves beyond the scope of one's own interests, and person in charge or the engineer itself must take into account of other people's interests. So now we are going to watch a short video on what is about utilitarianism.
Hi, I'm Julia Markovits, and I'm an associate professor of philosophy at MIT. Today, I'm going to talk about utilitarianism. So I spend my time thinking about morality, about what makes actions morally right or morally wrong, and I wanted to talk today about a very simple, quite popular answer to that question, a moral theory that goes by the name utilitarianism. Utilitarianism has a lot going for it, but it also raises some very interesting worries, and I'm going to talk a bit about some of those. So utilitarianism is the view that actions are morally permissible if and only if they produce at least as much net happiness as any other available action. In other words, the more happiness and less suffering that results from our actions, the better the action is. And the right action is the one that produces the greatest balance of happiness over suffering. In fact, according to utilitarianism, any other action is morally wrong. This utilitarian principle is supposed to be absolute and all-encompassing. It will tell you for any decision whatsoever exactly what you should morally do, and it admits of no exceptions. Utilitarianism has been around for a long time, but it gained a lot in prominence and popularity in the late 18th century, due in part to the work of a British philosopher named Jeremy Bentham. Bentham published a long defense of utilitarianism called An Introduction to the Principles of Morals and Legislation in 1789, But he was also a very politically and socially active guy. In fact, he was an early defender of economic liberalization, freedom of expression, the separation of church and state, women's rights, animal rights, the right to divorce, the abolition of slavery, the abolition of capital punishment, the abolition of corporal punishment, prison reform, and even the decriminalization of homosexual acts. Remember, this was 1789. Bentham recognized the moral importance of these rights, many of which are now uncontroversial. In this, he was well ahead of his time, and in large part, I would think, because of his embrace of utilitarianism. That, for me, counts heavily in favor of it as a moral theory. And in fact, aspects of utilitarianism can look very hard to resist. We can break the utilitarian thesis up into two parts: a theory of what is valuable and a theory of right action, given what's valuable. First, the theory of what's valuable. It says that the only thing that's valuable in its own right is happiness and the absence of suffering. Other things, like money, might be derivatively valuable because it helps us get happiness. Second, the theory of right action. The right action is the one that maximizes, produces the most of what's valuable, or if that's uncertain, that produces the most expected value. If you put those two pieces, the theory of what's valuable and the theory of right action given what's valuable, together, you get utilitarianism. Here's a very simple example. Let's say I'm a doctor and I have only 5 doses left of some very scarce medicine. In an emergency situation, I'm left with 6 patients, all of whom need the drug to survive. But one of them, let's call her needy, will survive only if I give her all 5 doses of the drug. The other 5 patients can survive on a single dose each, and we can assume that I know nothing else about these patients. Utilitarianism will tell us to divide up the drug, saving the 5 and allowing needy to die. Why? Because saving the 5 lives preserves much more happiness and prevents much more suffering than saving just 1 life. And in that case, that seems like the right answer. It's important to notice that these two elements of utilitarianism can be separated. We can accept the utilitarian view of what's valuable without embracing its claim about what that means for how we should act. And we can accept the utilitarian claim that the right action is the one that makes the most value without accepting the claim that happiness and the absence of suffering are all that's valuable.
So okay, move on to the second subtopic, which is the code of ethics. Code of ethics or code of conduct. What is code of ethics? It is actually a set of rules that's supposedly to be followed by the engineer when executing their professional field of practice. So generally, the code of ethics lays down a few general guidelines. An engineer must have a relationship or transaction to God, to environment, to community, to peers, to client, or even to the employer. For example, if you are an electrical engineer, the IEEE has listed down their own code of ethics, which is the first one is to accept responsibilities. When making engineering decision, the decision must be consistent with the safety, health, and welfare of the public. And an engineer also must take responsibility on the danger that might cause harm to the public or even to the environment. And the second code is to avoid any conflicts if possible. And the third code is to be honest and realistic. An engineer must be honest and realistic on the job and on the work they do. And the fourth code of ethics is to reject any bribery in any form. And the fifth code is to seek, accept, and offer honest criticism of technical knowledge and correct errors. And the credit must be properly contributed to the person involved. And the last code of ethics will be to assist colleagues and co-workers in their professional development and to support them in following of the code of ethics. So okay, move on to the last subtopic, which is the professional negligence and liabilities. So what is actually professional negligence? Professional negligence is basically a breach of duty of care between the professionals and their clients. So clients usually expect a level of professionalism and standards commonly held by those in the profession. So professional negligence can be divided into two, which is unintentional negligence and carelessness negligence. For example, a fresh grad engineer in his early stage of working life, he may collect a few shortcuts when doing their job. These shortcuts is usually received from their superiors, colleagues, and others involved in their profession. So these so-called shortcuts um, often referred to as the rules of thumb, and the job is completed fast with minimum expenditure of resources. In the end, the engineer that involved in this kind of problem could face a professional negligence lawsuit. Okay, next we are going to watch a short video on what is actually professional negligence.
In this video, we will introduce negligence. We'll say Perry is crossing the street, and just then, Dudley comes riding by on his bicycle into the intersection too fast, and there's an accident, and Perry gets hurt. In everyday conversation, we would say that Dudley was careless, and that his carelessness caused the accident. But if the parties go to court, we would say that this is a case about negligence. The defendant is being sued for being negligent. Negligence is another name for an unintentional tort. In law school, you'll frequently hear people say that a plaintiff must prove duty, breach, causation, and damages to win a negligence claim. That's a short way of saying that the elements of negligence are the defendant owed a duty of reasonable care to the plaintiff, the defendant breached that duty of reasonable care, and as a result of the breach, the defendant caused damages to the plaintiff. So using our bicycle accident as an example, let's look at the elements of negligence: duty, breach, causation, and damages. And we'll start with duty. By duty, we mean that the defendant had an obligation of reasonable care to avoid causing this type of injury. To determine whether that obligation exists, courts will often ask whether the accident and the injury were foreseeable. In this case, everyone would probably agree riding a bicycle too fast through a crosswalk can foreseeably cause an injury to a pedestrian who is crossing the street. For this reason, the element of duty is probably satisfied. Dudley had a duty of reasonable care to avoid this type of injury to Perry. Next, let's look at breach. To determine whether Dudley breached his duty of reasonable care, a court will probably compare Dudley to the reasonable person. If the defendant's level of care went below the level of care that we would expect from a reasonable person, we would say the defendant breached his duty of care. So using this chart as an example, we would say that whenever the red line goes below the blue line, the defendant breached his duty of care because he showed less care than the reasonable person would. Turning back to our case, people would probably say that a reasonable person would not speed through the crosswalk, and instead, a cyclist would slow down or stop. For this reason, Dudley was not as careful as he should have been. He was not as careful as the reasonable person, and therefore, he probably breached his duty of reasonable care. Next, we'll look at causation. At this point in its analysis, a court will ask whether the defendant's breach of his duty of care caused the plaintiff's injury. In fact, courts discuss two types of causation: actual cause and proximate cause. We're not going to discuss those in too much detail, but actual cause means if the defendant had done something differently, would the accident still have occurred? For proximate cause, we ask whether the defendant's actions were close enough in time and space to the injury. Based on the facts as we understand them, it seems the defendant did cause the accident, because if he had stopped or ridden more slowly, there would not have been an accident. So it looks like the third element of causation is also satisfied. Now let's look at damages briefly. It seems that there's no dispute that the plaintiff was injured as a result of Dudley's actions. Therefore, we can say that all four elements of negligence have been satisfied. We can predict that Perry will win in his lawsuit because he should be able to prove all four elements of negligence.
Okay, I think that will be all for this presentation on this topic, 4.3 Engineering Ethics. Goodbye and Assalamualaikum, and thank you for watching.